Hi, hello guys, this is Vijay, chemistry lecturer from Ailabad Junior College. As you know that we have started our NEET series and we are discussing about each and every chapter in detail in chemistry as well as in biology. Okay. So this is the apparatus J.J. Thomson he used for the determination of charge by mass ratio, okay, of electron. Okay, you see in this apparatus you see here there are two electrodes are placed, cathode and anode. Yes, there are two electrodes and these two electrodes are connected with a high voltage of DC, high voltage electric current which is supplying. And apart from this you see actually this is the path of the cathode rays which is traveling from the cathode rays to anode rays, where if we place a magnet and also if we place an electric field and a magnet, so magnet could produce magnetic field. So these two fields are placed perpendicular to each other, then what will happen for the movement of this cathode rays? So let us discuss one by one. So when we apply this electric field, if the magnets are not there, only we are applying for the electric field, so these rays are deviated towards the electric field. So this is considered to be the spot A. Then if there are no field is applied, whether electric field or the magnetic field, no field which we are going to apply, so directly these cathode rays which is falling on the fluorescent screen, that is spot B. Similarly, if you remove this electric field and if you are placing a magnetic field, it is going to deflect towards the magnetic field. Yes, that is spot C. This experiment would help him to find the charge by mass ratio of the electron. That means E by m value. So E by m value of an electron, that is equal to charge by mass ratio of the electron, that he could calculated, and it was around 1.758820 into 10 to the power of 11 coulombs per kg. Coulombs is nothing but is a unit we are using for the electrical charge. The electrical charge we are using, I mean the charge of the electron we are using for the unit coulomb. Similarly, the mass of an electron, mass we are going to consider for kg. Okay. So 1.75 into 10 to the power of 11 coulomb per kg. This is what the E by m value of electron. This could be calculated. Then we might have question, yes, related to this. How would we determine the charge of an electron then? How would we determine the charge of an electron? So to find the charge of any fundamental particles, it is not only electron, proton. So the determination of charge of the fundamental particles is measured by R.A. Millikan. Yes, it is measured by R.A. Millikan by doing his experiment in the year 1909. So what experiment he could perform to find the charge of an electron? That experiment is popularly called as Millikan's oil drop experiment. Millikan's oil drop experiment. Okay. So now let us see how this experiment could be possible, and from this experiment how could we determine the charge of an electron. Let us see how to do this. Okay. So now let us discuss the determination of charge on the electron by Millikan's oil drop experiment. Okay. Determination of charge on electron. So charge of an electron or charge of a fundamental particle could be determined by R.A. Millikan by doing his experiment in the year 1909. Okay. According to this experiment, he concluded that the fundamental particles are having certain charge. So based on that, electrons which possesses the negatively charged, proton which possesses positively charged. So how he did this experiment? So actually this is the experimental setup, and this experimental setup is called Millikan's oil drop experimental setup. Okay, so look at this apparatus. In this apparatus, you see there is a small hole which is present at the top of this plate. Yes, the charged plate. So this charged plate has a small hole. Through that hole, there are one oil spray which is placed at the left side of this top corner. So this oil spray is helping for spraying of oil drops through this hole, and that will fall into this experimental setup, and it will fall on this charged plate. But few drops may escape through this hole, and these drops can be seen. The drop of this oil droplets which is coming through this hole can be seen by a telescope which is placed at the left side of this apparatus. So through this telescope we can able to see the movement of oil drops from this hole. Okay. Similarly, there are one more hole on the right side where the X-ray which is produced by the substance, radioactive substance, and this X-ray could be able to charge on the oil droplets which is falling through this hole. So this X-ray which is charging the oil drops which is falling from this hole where this the charged plate is there. Yes. So this is the experimental setup. Now how this experiment can be done? Let us see. So initially what happened, small drops of oil which is falling from this oil sprayer, yes, and that could able to form as in the form of mist, and these are formed by a sprayer, and these are allowed to fall into these two different metal plates. These two metal plates are charged metal plates, and few drops which could able to go through this hole where this charged plate which contain at the center of this plate. Okay. So a single drop between the plates which is observed by means of the telescope which we are using, yes, at the left side of this apparatus, and this telescope could be able to observe the micrometer level eyepiece. So here we have an eyepiece that ranges for micrometer. So even the small particle could be able to see through this telescope. Okay. So now the oil in the form of mist which is dropping, falling through the air under the influence of this gravitational force, because as we know that any object which is existing on the atmosphere, yes, any object which is existing on the air, obviously it is attracted to the earth by means of this gravitational force. So these oil drops are attracted to this downward due to the gravitational force which is acting on these oil droplets. Now these oil drops are irradiated the space between the plates with X-rays. So here two plates we kept, and through that we are passing this X-ray. What would happen? These X-rays which is falling on this oil droplets, yes, so that would make that oil droplets to get charged. Now you see, by charging these two plates which is placed inside of this apparatus, the upper plate which we are going to charge this plate, and that would act as this positive electrode, like this lower plate that could be charged by the electricity, that could act as the negative electrode. So now what happened? By adjusting the electric field strength, by these two, the positive and negative electrodes plates which is placed in the apparatus, so that would make that oil droplet to go against to the gravitational force, So gravitational force which is pulling down the oil drop from one side, the other side these two plates could be able to create the electric field, and this electric field is pulling the oil droplets towards to the upwards direction. So these both forces acting together, at finally what happened, the oil drop which remained stationary at one point. So that could be adjusted by the supplying of electricity through these two plates is possible. Okay, so from the amount of this charge on the plates and mass of this droplet, the charge on the droplet that could be able to determine. So the mass of the droplet, oil droplet, was determined from the rate of falling of the oil droplets through the air when the plate which is uncharged. So by the way, we can easily understand the determination of charge of an electron of this oil droplet. Okay, so finally by doing this experiment, Millikan could able to calculated the charge of an electron of these oil droplets, and that could ranges around 1.6022 into 10 to the power of minus 19 coulomb. So this was actually the charge of an electron he could able to determine by conducting this experiment. Though the electron possesses negatively charged, so the value we could get minus 1.6022 into 10 to the power of minus 19 coulomb. So by this way, the Millikan could able to perform his oil drop experiment. Now look at this picture, you can able to understand this experiment in detail. Okay, now we are going to discuss about the discovery of proton or discovery of anode rays. Similarly, the earlier one what we discussed, the discovery of cathode rays and discovery of electron. Okay, that credit goes to J.J. Thomson and his team. Actually, this experiment, it was conducted by Goldstein in the year 1836. So this credit goes to him who discovered the discovery of proton by conducting the study of anode rays. Okay, so he also conducted this experiment by doing the same experimental setup as earlier we are discussing about the cathode ray experiment. So similarly, he also conducted the same method, like when he did this experiment, in addition to these cathode rays, there are a few rays which are he could able to find behind the cathode discharge tube. Okay, so how he made this cathode as a perforated cathode. So through this perforated cathode, there are few rays which is passing from cathode electrode to the anode electrode. There are few rays which are passing from this cathode to anode. There are few rays which are starting to traveling in the opposite direction to the cathode rays, and these rays he could called as the anode rays. Why he could call us this as anode rays? Because these rays which are also getting deflected by the magnetic field and also the electric field, like similarly like these cathode rays. Okay, so but the reflection of these anode rays which is the opposite direction to the cathode rays. So by this way he conducted this experiment. So in this experiment he concluded that these few rays which is going opposite direction to the cathode rays, which are considered to be called as the anode rays. It is also called as canal rays. It is also called as canal rays. Though these rays are passing through this perforated cathode, so it is considered to be canal rays. Okay, so now you see the charge and mass particles which is constituting the anode rays, I mean the canal rays. This also, unlike the cathode rays, like the charge to mass ratio of anode rays, which was found to depend upon the nature of the gas what we have considered in the discharge tube, nature of the gas. So based on that gas, this could be calculated. Say for example, in case of hydrogen, the charge to mass ratio was maximum, because the value was found to be 9.58 into 10 to the power of 7 coulombs per kg. So its charge that has been found to be similar to that cathode rays electron charge, that is 1.6022 into 10 to the power of minus 19 coulombs. Okay, and that is equal to the magnitude but opposite in sign to that of the electron. That is the reason the value could be considered as 1.6022 into 10 to the power of minus 19 coulomb is placed by plus sign, because though the particles present in these anode rays or the canal rays which possesses positively charged particles, so this has 1 unit of positive charge. That is the reason these rays are to be having the charge of 1.6022 in 10 to the power of 19 minus 19 coulomb. Okay, so this also experiment similar, this is the experiment similar to that cathode rays, but here we are going to consider that the anode rays could be found by depending upon the nature of the gas which we have taken inside this discharge tube. So by this way the Goldstein, who could able to determine the charge by mass ratio of the particles present in anode rays or canal rays, and also he discovered these anode rays or the canal rays, they possesses the fundamental particle called proton. Okay, so this credit goes to Goldstein in the year 1836. Now So this could conclude this today's session of NEET chemistry in detail about atomic structure, and this chapter we will continue with one more video with further more topic. Until then, thank you guys.